Today, the agenda is very simple. In previous class, you know how to implement state machine, and also you know how to write for asynchronous, programming like preset and clock everything. Okay, that you know already. Asynchronous operation, how to achieve in Vsdl. These two things already I have discussed.
Excuse me, sir.
Yeah.
Sir, like from my side, I'm unable to hear you clearly. Like your voice is too low.
Okay.
Me too, sir.
Okay. Okay. So can you confirm that now it is okay?
Yes, sir, much better than previous. Sir, can you bit close, like move a little bit closer to the microphone?
Oh, good. Just a second. Actually, my volume of the speaker was low.
Yes, sir, fine right now.
Yeah. So can you
Yes, sir,
confirm?
fine.
Is it fine now?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay. 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 Thank you. So let us start. Uh, the thing is that today I will do the VSDL code for shift register. Okay. Basically, shift register I will do. Now in the shift register, you know there are four types of shift register. Okay. One is serial in, serial out. Okay, and then parallel in, then parallel out. Okay. Then vice versa. Serial in parallel output, parallel in serial output. So four types are there. So first, I will do maybe like this serial in parallel out, okay, because it is used quite extensively. So I will do that. And 4 bit. So 4 bit serial in and parallel out. That I will do today. Shift register. Okay. So before I start, you know that the shift register is basically, the basic concept is it actually changes, the state actually changes. So let us say I have having one high signal, okay, this is one state, and let us say this is the final state. So in the next state, you will find that the next bit will be higher, and then it will reach to this. In the third clock, and you think, you imagine that for each clock, basically clock is moving, okay, and here Q1, Q2, these are all bit, and here clocks are moving simultaneously. All clocks are moving, and I am taking the rising edge clock. So changeover happens in the rising edge. So this is the first, and second rising edge will be here. Okay, so I have drawn consecutively. Okay, but you just imagine that this will happen. The next stage is that it will be once again, it will be high. Okay, and then it will once again. Okay, then it will be once again zero. Then it will be high. So basically, the state is moving. Okay, from the lower position to the higher position. If you consider this position to be 0, 0, 0, 0, 4, because I am talking about 4 bit operation, so it will be moving from the lower side to the higher side. So this is a simple explanation of the shift register, but how we could write in VSDL, okay, or using VSDL. So VSDL code for this would be very simple. First, I have to just declare the library, and then I will just go for the code declaration. And you know, in the code declaration, I need to have one input, because this is the first input I need to provide. Okay, and the clock input definitely I need to also provide. And based on that, the next state will change. Next state means Q1 to Q2, then Q2 to Q3. That will change. Okay, so this process I have to complete. So first, let us just write the library IEEE, then use standard logic. So use IEEE, I think, yeah, IEEE standard logic 1164 dot org. So this is library. I should not discuss on that. It is already common. Now entity shift register SR, let us say. shift register is now now I have the I mean I need to declare the port. Okay, so port. So can you tell me that in the port what I have to write? So X is the input, let us say. Okay, so X is the input and it is what? Standard logic. Is that clear to you? And now what I need? Clock. Now in the clock, that clock is what? Clock is also a standard logic. Okay, it is input standard logic. Okay, what else output I need? Anyone? In the shift register, the 4-bit shift register. Okay, so let us say that I have one this kind of 4-bit serial in and parallel output. 4-bit shift register. What will be the output? You tell me. And what should I write here in place of the output? See, this is one output, this is one output, this is one output, this is one output, right? So these are the basically four outputs. Now I can write the output variable q as a vector and two
Yes, sir.
position
As
and
a
three
vector
position.
3 down
So
to
I
0.
can consider
Yes.
that q as the output as a vector, and the whatever you say that you can write. So I will write in place of the output which is q. Q is equal to another important thing. Whether I should write the simple output or what?
In out, sir.
Whether I will write simple output or what? In out. Why? Because this is the clock, let us say, and you are giving an input here x. So this is your clock, okay? And then these the output will be coming to the second one, and second one will be coming to the third one, and this you are taking as output. So you see, this variable is output, and also this variable is input to the second flip flop. Okay. So in that case, the first this q whatever I cannot say it is only output, so it has to be in out. So q equal to in out. Okay, that is very should be very much clear. Okay. Now standard logic, std logic. Then standard logic vector, because it is
Sir, you are not on.
Sir, you are not audible right now, sir.
okay. I don't know what happened, but I have disconnected. Okay, my voice is clear. Can you hear me?
Yes, sir.
Okay, up to
Yes, sir.
what I have discussed. I mean before disconnection.
Sir, can you explain the last line again?
Yeah, I can explain. I can explain. See, actually, I am going to design 4-bit shift register. Okay. So as you know, each flip-flop can be represented by one bit. Okay. And here, what I am doing, serial in and parallel output. You can see this is the serial in, and the parallel output I am taking from each flip-flop. Now the point is that already X is the input. So it is a simple input vector. So it is a simple, I mean, a standard logic. So only input standard logic will be true for the input. Now clock is also in need, and clock is also an input standard logic. However, the output you can take like this. You can take like Q1, you can take like Q2, you can get Q3, and you can Q4. Okay, and you can write programming for Q1 to Q4. It is possible. But why you will write for each output? It is just a wastage of space, as well as the programming style is not also good. So in place of writing each individual output, I can club it to a vector. So I just have taken q1 to q4 as a vector, which you will start from 0 to 3. Basically, shift register starts from lower value to it goes to the maximum higher value. Okay, or basically up count, you can say 0, 1, 2, 3. Generally we do like that. Okay, but if you say that whether I can write 3 down to 0, absolutely you can write, there is absolutely no problem. You can start from higher position, you can go back to the lower position, but generally we start from the lower position and go to the top. So that's why I have written in a vector form, and the vector form is like a standard logic vector 0 to 3, and the initial value, let us say I am giving a fast clock. Okay, so during that time what will be the output? After that, that output will change, okay, for each bit of operation. But the thing is that initial output, if you do not provide, then the system will be problematic, because you see, if you are not giving any kind of output here, so the second flip flop output depends upon the output of the first one, and the fast output will only complete when you have a rising edge of the clock. So since the fast clock event happens, then the output of the first flip flop will change, and that will impact to the change in the output of the second flip flop after another clock. So you initially 2 3 clocks you will not get any kind of output if you do not provide any initial condition. Okay, so to avoid that, you initialize that output to be 0. Now, having said that, can I write only output? Okay, let us say I am taking the 4 output vector or 4-bit output vector. The thing is that whether it is only output, the answer is no, it is not only output. You see, the output of the first flip flop is actually an input of the second flip flop. So, if you consider q as a variable, so q is not only output but also is the input to the second flip flop. So therefore, I have to write in out in place of only out here. So that's why I have taken q to be an output generalized variable. Okay, it is not q1, q2, q3, q4. It is, you can see, if I ask you what is q0, so q0 will be output of the 0 or first flip flop. Okay, so I have taken an inout and standard logic vector, and which starts from 0 to 3, and it starts from 0 0 0 0 value. Okay, that is the meaning of this line. Is that clear to you?
Yes, sir.
Now I have to end the port. Okay, so port this is over. So now end what? End SR, because I have taken SR. Now what else I have to do to, let us say, architecture. Architecture behavioral of SR is, okay, then begin the program, and I do not need any signal here because it is straightforward programming, so I do not need any kind of signal. Process, definitely clock you need to process, otherwise you cannot program. Then once again you need to begin. Okay, and you see, interestingly, in this program I haven't used any clear. Okay, I haven't used any clear. If you want to use, you can use. So this clear will be common, and that you can write if clear equal to 1. So that is, you can do, but I am not doing. Okay. So I already told when I have explained about the clear signal. It is not that you always have to do. It is up to your choice whether you want to do it or not. If you want to do here, you can just write a single sentence equal structure, then you can write your code. Okay. I am not using any clear here. Okay. So now begin. Then you tell me what I have to do after begin if. Basically, I have to start with the if, right? So begin if. So what I will consider. I already told you that the change of the fast flip flop will happen only if you are using a rising edge clock or maybe a falling edge clock, whatever. So I am taking a rising edge clock. So rising edge clock event, whenever it happens, there will be a triggering or a change of the output starting from the fast flip flop. Okay, so what I will do, I will write rising edge if rising edge okay, clock, then you tell me then what I should do. Very interesting question. I have already written. This is the thing. Okay, if I have to do the clock is changing or rising edge is happening. Let us say rising edge. Let me draw two, three, clock event or timing basically. So let us say this clock is moving, okay, continuously, and the clock is a rising edge clock. Now you tell me that how the system output will change for a shift register. Let us say this is Q0 and dot 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 line, and it is Q1. Okay, that is also dotted line. You tell me how the system output will change. Anyone? Hmm?
So everything will become zero initially.
Okay, so this initial value, that Q0 initial value will depend upon the value of X input. Okay, but the next output Q1, it will depend upon the first output. Okay, and if you consider Q2, Q2 will depend upon the first output or Q1 output. If you draw it carefully, let us say Q0 value is 0 here, or you can say that, let us say it is 1, okay, for that particular event, that is 1. Okay, so the Q1 will be high here in this particular clock event. It is just moving this direction, and Q2 will just obey the third clock, and will follow this output. Okay, so you see, can I write like this? So basically the output of Q2, okay, the output of the Q2 is basically the output of the Q1 in previous state. Is that clear? Can I repeat the sentence? The output of Q2 in current state is same as the output of the Q1 in previous state. Is it clear? Do you understand this thing or not?
Sir, once again, sir.
The present state of Q2 is equivalent to or same as the output of Q1 in previous state.
Yes, sir.
Okay, so that is the concept of the shift register, because it is shifting from position 1 to higher position. Okay, so now I will simply write like this. So Q, okay, 1, 2, 3. Okay, so here 1, okay, 1, 2, 3 is actually equals to Q 0 to 2. You understand? So this Q0 is basically shifting to the Q1 if in the next clock interval. Is that clear to you? So this line I can write. So Q of 1 to 3, which is the current state, is same as the previous output of the previous flip flop. So Q1 to 3 is equal to Q0 to 2. Okay. And what about Q0? So somebody can say that what is Q0 then? Q0, because the Q0 previous thing is not mentioned. So Q0 is equal to simply X. Okay, so this logic I can directly write. So you try to understand. So this type of thing you have to apply when you are solving some, maybe some problem or real time problem. Okay, so Q, I can directly write 1 to 3 is same as basically Q 0 to 2, and Q0 is the same as the input X. Okay, now there will be no problem. See, Q0 already equal to X. Okay, if you know this thing, then for each clock event is just basically passing the data to the next position or next stage. Okay, is that clear to you? This is the main important story of this. I mean, the 4-bit shift register serial in parallel output. Okay, because each bit is we are taking from output. These are all output. Now you have to end the process. So end if, and end process, and end variable. So program is now over. So it is So end if, and then what? End process, because process also I have to end, and end behavioral. Okay, only these two lines are important. Okay, rest of the things are not that important. So only this thing. For each rising edge clock, how you assign or how you put this variable in this way is important. Okay, is that clear to you? Can you write now by yourself? Is it clear? Any question you want to ask regarding this?
So this is how we'll be getting the output then, sir, because now we have done taken the input. Now it's in serial and parallel out. So we need output at every stage. So how will be
See,
taking that?
this is one flip flop. Okay,
Yes,
this
sir.
is the second flip flop, and the output of the first flip flop I already told you it depends upon the X input.
Yes, sir.
Now, in the so what will happen to the then during this event? So what will be this output? Let us say the clock actually changes here. Okay, so this is the clock. Now the question is that this clock event when it changes, output definitely okay. X input is coming, so this Q1, Q0 you will get. But what about this Q1? What will happen to the Q1? So Q1 will pass the previous value of this Q0. Okay, and you see I have already mentioned 0000 is the initial output for each one. So this 0 will be then transferred to this Q1, and then and also the initial value of the Q1 is 0. So this Q1 also will be passing to the next, so Q2, and that the 0 will be passing to the next, which is Q3. Okay, and let us say for simplicity x equal to 1. So what will be the output will be 1 0 0 0. Okay, now after that here there will be one 0 position, and then once again a rising edge clock happens. So let us say there is another rising edge. So during this rising edge what will happen? That during this rising edge there will be another changeover. Okay, so already the previous output of q0 was 1. Now in this one will be directly transferred to the second one. So if you are not giving any input for, let us say, x is, you are not giving anything. Okay, so what it will do, it is invalid. Either it will give 0 or 1, it do not change, it's invalid, and then it will go to the next stage. Okay, and this value will be shifting here, this value will be shifting here, and this value will be shifting here. So 1 then 0 then 0. Okay, and if you go for the next clock event, another clock event rising edge, then what will happen? Cross, this one will be shifted. So 0, sorry, this is 1. Okay, and then this is 0, and finally cross, and then 1. Okay, so you see this output are basically input of the previous one. Okay, that's what I have written here. And what is the initial stage? Initial stage is 1, is depends upon the value of the x. Okay, so as far as programming there will be no problem. See, this programming is useful in running light. So I think you have done this kind of programming in C also. Let us say I am having one, two, three, four lights are there. Okay, so first this will on, then second it will this will on, then third it will on, then fourth it will on, and then it will repeat. Okay, this will on like that. So running light also you can generate by this code. Okay, so is it clear to you now?
Yes, sir.
Yes, sir.
हम्म, बोलो, अगर समझ में नहीं आया मैं फिर से रिपीट करूंगा, बोलो, because this concept is important. Okay, so only these two lines.
So in any shift register, if
Hmm.
when we take a initial condition, so that number goes one by one in the one of the flip flop, like
Hmm.
one bit is equal to one flip flop, right? So
Hmm.
when if you are taking four zeros, let's say 1000,
Hmm. Hmm.
so first zero will be getting into the last flip flop, then accordingly the first stage will be zero, then don't care, then
Okay.
00 don't care, and then again 30 don't care, then 100, right? This is how it goes, right?
Mm-hmm.
So in
See,
that, yes sir.
you can see what is the thing. So you can go like that. Okay, let us say this Q3, Q2, okay, Q1 and Q0. Okay, so let us say you have 0, 0, 0, 1, and then you will write 0, 0, 1, then invalid. Then, so I think you are saying about this, right?
Yes sir.
Uh, See, the same thing I did in different way. I have started from 0. Actually, I have
Yeah,
started
okay.
from 0 to
Okay sir.
3. The
Yes sir.
same thing I did actually.
Right sir.
You are starting from this position to this position. Okay, I have drawn in opposite way. Basically, I am
Right
doing
sir.
the same thing.
So we have already loaded, it's not empty there, so that's what we have considered.
Because you see, otherwise, if you do not load na 0 0 0 0, then you cannot do this thing. Otherwise, there will be problem. This sentence will have no meaning then.
Okay sir.
Okay, now having said this thing, now can we do now that what is called maybe a shift register for parallel output? Hmm? Can you do it, or I will have to do?
So we'll try it first.
Okay, so what I will do now, let us say I will do the synchronous up counter then. Okay, shift register I have done, so you practice. Okay, otherwise I will do. So what I will next I will do, I will just write a code for maybe up counter. Okay, so in synchronous up counter, that let us complete synchronous up counter. Okay, synchronous up counter. Now I have to some questions to you. So as you know, the meaning itself, when I am saying that it is a synchronous up counter, it means what? Means what are the elements you actually require? First, tell me, I am going to design for 2 bit. Okay, you tell me what are the things required. After that, I will write the code. First is basically two flip flop. Yes or no?
Yes sir.
Okay. Now next another thing that what clock is required, and it is synchronous. Synchronous mean that clock is common to both the flip flop. It is also important. So here this clock is common to both the flip flop. Okay. Is that clear? Now we'll write the code. Is there any other thing you need to know here? Can you do it now with this knowledge? Till now, what I have already taught, with this knowledge, can you write the code for this kind of synchronous up counter? Hmm? See, you have one more variable. See, whenever you have common, na, this common clock is there, and based on that, you have to see the output change. Then, and also some arithmetic operation you have to do. So the thing is that you need some numeric, otherwise you cannot do. Hmm. So in libraries, let me write the code. Library IEEE. Then use IEEE dot standard underscore logic 1164 dot all. Okay, and extra this thing you have to add. Okay, this is the first time I'm using. Okay, till now no, in whatever programming I taught you using Vsdl, I never used this thing, but now it is required. numeric standard all. Because otherwise I cannot define 00 or 01. Okay, this thing I will use now. Okay, so that is the library. Okay, so this thing is a new thing. Okay, I am making it as a underlining thing. Okay, this is the new thing. Okay, except that this already you know. Okay, this is the numeric standard, and why the numeric standard I am using as a library, because I need that help. Okay, otherwise I cannot solve the program. Okay, now after that I need to define the entity. Okay, so what I will use, entity or port. Entity, what is that? Synchronous counter, so SC is port. Now I will not say anything, you say that x equal to, sorry, I have already told. You tell me x is what, the input. Okay, so the first input x is what, is the input, standard logic. Okay, now you tell me for the what I will write, what is the output, or is there anything else required? Clock is what I will write in standard logic. Okay, now you tell me that what I will write now. Up count and down count. See, I already told that I am interested in to design for up count. So 0, then 1, then 2. So I am interested to design up count basically. Okay, 2 bit means 0 0 0 1 1 0 1 1. Okay, so 0 state, 1 state, 2 state, 3 state. So I am going to design that. So who will guarantee whether this is up count or down count? Means you starting from 0 to 1, and then 1 to 2, then 2 to 3, and 3 to means 0. Who will guarantee that? In theory, you have studied. In digital electronics, you have studied. Tell me.
For count variable you can use.
Hmm? See, for that, do you remember one thing, that there is most significant bit? If it is 1, then it is down count. If it is 0, it is up count. This kind of thing you remember or you forgot? Okay, anyway. So I am. So you please revise. Huh? These things are there
Yes, sir.
in the. Okay. So now next, I will have to take Q as the output. So it is in out, and is so in out. Now you see the state. Okay, so this state is the output, 0, 1, 2, and maybe here 3. So this is actually numeric. Okay, so I will not write that in out standard logic. Rather, I will write like signed, because that is why I need actually this numeric. Otherwise, there is no need. SIGNED, signed. Okay, and what is that state? So you have basically two flip flop. So I have one variable and two variable. Okay, so I will write like this. So 1 down to 0, 1 down to 0. Okay. So see why I am using signed. Okay, I can use simple, that in out standard logic vector. Okay, then 1 down to 0 and starting from 0. That I can do, no problem. But the question is, who will say, or who will give you the guarantee that the count will start from low side and it will go to the upside? So you need to have to track over this MSB, or most significant bit of the particular, the data. Okay, I am using 2-bit data, so most significant bit will determine that what I should go for. Therefore, I need to use a sign. Otherwise, there is no need of the sign also. I can directly write the standard logic vector 1 down to 0. But I should not do that, because I want to implement up count. Okay, and that is why the reason I am using numeric standard, and signed 1 down to 0 is used. Okay, and let us just initialize the value. Initialization is 0 0. Let us erase this part, you erase. Okay, so this initialization part is over. So I am giving the value. So I am using a signed thing. Okay, based on the signed, I can conclude that whether it's up count or down count. Okay, so that part I have completed. And 0 1 down to 0 means basically 2 bit I am taking. So that is why 1 down to 0. Initial value is 0 0. Okay, so this part is over. And why this in out? Because the second output will also depend upon the present input. That is why I am using an in out. Okay. Is there any other thing required here? Why the output? Final output is required. And initial value of the output should be 0. See, one important thing I need to mention here. See, I am using a vector 1 down to 0. That's why I am taking double inverted comma. And I am using simple logic, standard logic. So that's why I am using a single comma. Okay. So the comma that is over. Okay. What else I have to do? I think this thing okay. So I have to end now. End SC. So here I have completed your port. Port definition is second step is clear. Now architecture. Okay. So you know that I need to go for behavioral model of architecture. Okay, so architecture I am writing. Architecture behavioral of SC is behavioral model SC is. So begin. These are easy. I think you know. It is very easy now. Process. I have to process the clock. Okay. And another thing I have to begin again the program. Okay. Now it is interesting. So I will what I will write. I will write rising edge. I will write a falling edge. What I will write because it's a up counter. Okay.
So I will take the rising edge.
Yeah. Let us take rising edge. Okay. Because I am taking always rising edge, so let us take rising edge. Okay. But you can also take falling edge. There is absolutely no problem. Clock. See, I am using if and then structure. Okay. I already taught this. If rising edge then. Okay. Then you tell me that what I should do. Okay, now I will write if x is equal to 1. Okay, let me go to the diagram. Okay, if x equal to 1 and clock is there, then what should be the output? Tell me, what should be the output? So the output should go to the next stage, right? Because it's up count basically. You have 0, so 0 should be to 1 and then it should go to 2. Okay, so it is up count. So basically the output, current output, okay, is the addition version or the next one position higher than the previous output. That is the meaning of this line. And if let us say you have completed the count, let us say if q is equal to 1 1, okay, it's a vector, so double inverted comma, and then I should assign y equal to what? Basically you see this x equal to 1. Okay, then what you have to do? 0 to 1, 1 to 2, so 2 to 3, so finally output will be 1 1. Okay, so then if q equal to 1 1, then what should be the output?
Okay.
That means fast count is completed. Okay, so fast count is complete means y equal to initially it was 0, then fast count completed means y equal to 1. Is that clear to you? See, once again I am repeating. You see this x equal to 1, then you are going for the next step. So 0 to 1, 1 to 2, 2 to 3. And finally when it reaches to 3, then 3 to 4 is not possible because ultimately 3 is the maximum. So definitely you need to stop the process. So definitely how I can do that? So if q equal to 1 1, okay, then output should change. So here in this case output was 0, but here what should be the output? 1. Okay. Else If it is not, let us say it is not, what will be the output? 0. Okay, and then other things are easy. So ultimately else is okay, then end if 2 times end if you have to do, because this is one if, this is another if. Okay, and also you have started from this part, 3 if. Okay, this is another if, this is the rising edge if, so I have to complete end if again, and lastly end process, and process is complete, then end behavior. So see how easily you can write the code. Okay, and you can design. The thing is that when somebody asks you to design up counter, okay, in a digital circuit, is a horrible experience. Okay, lot of chips are there, lot of things you need to compile, everything is I mean connection is very difficult. Okay, you have to manage the thing, but here you see, if you know the code, okay, then it just you have to write the simple rising edge, you have to take a clock, and then the next step, because of the I mean input, you just change the state, and when the maximum state is reached, then you just say that okay, the count is completed, so now output is 1, and you complete the program, or you just stop the process. Okay, is it clear to you? You understand it?
Sir, once again, can you explain the code part, sir? Like, I missed out.
Okay, from where I should start,
Like,
from the
sir, from the rising edge.
okay, from the rising edge. Okay, so see, as it is a synchronous counter, so synchronous counter, up counter, it means that clock will be common for both the flip flop, and I am doing for the 2 bit, so there are two flip flop. Okay, so the clock changes will change the output of the two flip flops simultaneously, because they are common to the. So how I can ensure the next stage, or change in the state then? So I can change, like let us say the clock is now changing from the rising edge from 0 to 1, then of course the the x input has to be 1, otherwise there will be no change, because I'm going from up count. So input is 1 means what will happen, if initial output was 0 0, I already told, let us initialize at 0 0, then what will happen, the clock will ensure the change of both the flip flops simultaneously, and it will reach to the next state. Next state means 0 1 state, so that 0 will be same here, and that will change to 1. Okay, that is actually our requirement, and next I want that it should be 1 0, and then it should be 1 1. Okay, and let us say this clock will continue, maybe 4 clock event, after first clock, the second clock, and third clock, and the fourth clock. At the fourth clock point, you actually reach in the state 1 1. Okay, and before that, the output y, it has to be 0. But when you reach this state, that means your count is complete. So you have started from 0 count, then 1, and then 2, and then 3, and finally at the 3 position your count is completed. Then what to do? When you have completed the count, so this q equal to 1 1, then the output should change from 0 to 1. So it only says your counter part work is completed. Okay, and then if it is not, okay, if it is not, let us say it is not, you have put the reset button or something like that, so it from the second state, it can go to once again the 0 state. Okay, and then once again repeat. So this thing can be done. Okay, and intentionally we can do different type of lighting sequence arrangement, traffic light signaling we can do. Okay, so we will not directly complete the count. Okay, rather we'll keep on looping the count, but sometimes what happened when the count is completed, so then what to do? So then output is equal to 1, otherwise it is 0, and another thing is just ending the if. Okay, so it is basically based on the present initialization. The x is basically 1 is initializing the count, and after that it automatically goes from 0 to 1 to 2 to 3 based on the clock event, of course, because clock event, if it is not processing continuously, this thing will not happen. And finally when it completed the count, so output should be 1. Okay, that is the program. Okay, is it clear to you? See,
Yes, sir.
this kind of coding I can only write because I have a synchronous clock. Always you remember this kind of coding what I am writing here. This I mean for this example, I can only write q equal to q plus 1 for x equal to 1. I can only write if you have a common clock, because here is a synchronous, so I am having a common clock. But if I ask you that okay, please complete the up counter using asynchronous, don't use common clock. Okay, please do not use any kind of common clock and try to achieve the up counter, same 2-bit up counter. Can you do it by writing this kind of code? The answer is no, you cannot do it. Okay, you have to do it in other way. Okay, so that part also in the next class I will do. So today I have completed the very important aspect of the program. First one, how to implement the shift register. Serial in parallel output example I have given. I already told you to practice for other thing, parallel in parallel outputs, everything. Okay, every possible combination. Then another important thing that if you have a synchronous up counter 2-bit, okay, that you need a common clock. And if you have a common clock, then how to ensure whether it's up count or down count. So for to do that, you need a numeric thing, and you need a signed version of inout 1 to 0, and you have to initialize 0 0. And then you have to write simple thing like based on the rising edge clock, how your output will change. And finally, if your output completes the count, that output should be 1. Okay, it should be changed from 0 to 1. That's the code. But I just request you, you please think that if I ask you to implement the same up counter, so 2-bit up count, that I'm asking you to think how to implement using asynchronous. Okay, not common clock. So not using common clock. Then how to implement? Okay, so please think. Okay, otherwise I will solve definitely. Okay, in the next class I will solve. Okay. And in the next class, I will also talk maybe the frequency division, and slowly, this Vsdl part, maybe the implementation part. I will just start like how to implement for a sinusoidal PWM, how to take the sinusoidal data, SPWM. Some example I will solve. Okay, real time example. Okay, if you have any doubt, you can ask me now. I'm stopping this here. Any question you have, you can